Get out of here. All right, gang. Shh. Again, we said in this question, we're giving you the rate of change of surface area and asking for the rate of change of volume. Okay? And the link between them is going to be the radius. So, since I know how fast the surface area is changing, we can rewrite the surface area, not rewrite, but write out the formula as 4 pi r squared. When we derive that, we're going to get dr dt and ds dt. We know ds dt, we can find dr dt. That's going to be useful because what we really want is dv dt. And you can see from the volume equation, if you derive that, you're going to get a dv dt and a dr dt. So if I know dr dt, I can find dv dt. And if I know ds dt, I can find dr dt. And I know ds dt. So we're going to derive s with respect to time. That's going to give us this, 8 pi r dr dt. And we happen to know that's, what's ds dt? 1. It's decreasing at 1, so it's negative 1, right? And the diameter is 10, so the radius has to be 5. Good, very good, Joseph. So dr dt, if you solve that, happens to be negative 1 over 40 pi. And r is going to be measured in centimeters. So this is going to be centimeters per minute.
That's really short.
You think so? That's not fast enough for you?
Yeah.
I'm sorry. All right, but that's not the answer they're asking us for, okay? I found that kind of presumptuously because we didn't even do dv dt yet. Again, like ahead of, I don't know. I found it ahead of time. Okay, we'll say. All right. Again, we really want dv dt, but when we derive dv dt, we're going to get that dr dt. So I knew I had to find that first. All right. But when we derive dv dt, which, I'm sorry, when we derive v, we get dv dt. The derivative is going to be 4 pi r squared dr dt. True? True. So dv dt, yeah? What's up? A 3? Because the 3, when we derive volume, we're going to multiply by 3, you're right. But that's going to be, if you write it out, it's really 4/3 pi times 3r squared dr dt, right? Well, I'm just canceling these 3's out. Okay?
Wait, when did we find out that r was 10?
Back when we had to find ds dt,
Oh yeah.
or dr dt, because it says diameter is 10. Cool? Right, Joseph?
Yes.
We want dv dt, and we know dr dt was negative 1 over 40 pi. Okay? So we are going to get that dv dt has to be, this is going to be 100 pi.
That's a lot of pi.
It is a lot of pi over 40 pi. And that ends up being,
Drop the negative.
oh man.
Looked at a 4 too.
Now we're gonna take out my points on the test.
What do you mean? 4 times 25 is 100, right?
You're right.
That's right. Yeah, so negative 5 halves.
Yeah.
What are the units on this? What are the units on this? Who can tell me? Who can tell me? Who can tell me?
Square centimeters per minute.
Yeah. Because it's volume.
That volume though.
Now, guys, we've been super loosey-goosey with the units at this point. But if you kept track of these, look, here's why it's cubic centimeters per minute. Can you come back here for a second? Look. dv dt is the radius squared. What are the units on radius? Just centimeters, right? So that's centimeters squared, and then we're multiplying it by dr dt. But the units on that are centimeters per minute. So we have centimeters squared times centimeters per minute, and that's where we get the centimeters cubed per minute from. We're not just making this up. Like, they are coming from somewhere. It's just right now, and it's probably bad, but we're just not focusing on keeping track of them the whole time, okay? Because we're not really changing units at all in the problem.